In this video, I'm going to show you how to systematically find the dual program starting with the primal. So step one is going to be to form the Lagrangian. So the Lagrangian, what it does is it adds a weighted sum of the constraints to the primal function. Okay, so the Lagrangian is going to be a function of x and lambda, where lambda is an Rm. X is an Rn. Okay, so the first thing we do is we add our objective function, C transpose X, plus our weight. And so we'll add a different weight to each one of the constraints. In this case, our only constraint is AX less than equal to B, but we want the form AX minus B less than equal to 0. Okay. So after we reorganize things, we get C transpose plus lambda transpose A, X minus B transpose lambda. So step two is now we're going to form the Lagrange dual function. And this is going to be a function of lambda. And we're going to take the infimum over x of our Lagrange function. And the reason we take the infimum is because it's the greatest lower bound of the elements of a set, and it's more precise than the minimum. So now we have to think about what is the minimum value we can achieve with no constraints on x. So if we take a look at this here, if this is positive, x can be negative infinity, in which case this whole thing would take on the value of negative infinity, which is not very helpful to us. So what we want to do is we want to make this constraint 0 in order to have a meaningful answer. So our answer is going to be negative B transpose lambda if C transpose plus lambda transpose A equals 0 and negative infinity otherwise. And the dual program is max negative B transpose lambda such that, and after reorganizing the constraints, we can actually get A transpose lambda plus C equals 0, lambda greater or equal to 0, which matches this one here.